So a warm welcome to all of you guys, those who are watching to video. So the last session we have discussed about the gamma functions and we ended up with the motivation of gamma function. So today I want to discuss about some problems associated with gamma functions. So the basic setup. So let us quick revise the setup of gamma function. So if I write the gamma of n, which is written as integral to 0 to infinity e to the power minus x to the power n minus 1 dx, which is equals to n minus 1 factorial. So this is the typical setup of gamma function. So there are some sort of remarks, and these things are important while solving some problems. So the first remark is the gamma n equals to n minus 1 and gamma n minus 1 for all n belongs to a positive integer. Okay, so next thing is that gamma n equals to n minus 1 factorial, and gamma 1 is always 1 and gamma 0 is infinity. Okay, and gamma n plus 1 equals to n gamma n. Okay, and this is a typical result we'll use in problem solving. So gamma of half equals to root pi. There are several ways to prove that gamma of half equals to root pi, so we'll see that. Okay, so let us solve a problem. So it is written that what is it is asked that the gamma of 7/2's values. Okay, so how to solve that? So let us write. So it will be gamma of, so let's split it out. So 7 of half can be written as 5 of half plus 1 in this format, right? And we'll break it down in the form of n gamma n. Okay, so that will be 5/2 gamma of 5/2, right? Since you can write it as the gamma n plus 1 equals to n gamma n, right? So it can be written, so again this gamma of 5/2 has to be split it out. So 5/2 times, again we can write this 3/2 plus 1. Okay, and this 5/2 times 3/2 and gamma of 3/2. Okay, so this process will be up to 5/2 times 3/2 and half of gamma half, right? So in the previous page I have introduced that gamma half. So see the value. So this gamma half equals to root pi. So it will be what? So 3 times 5, 15 over 2 cube, that is 8, and gamma, so that is gamma half, that is root over pi. Okay, similarly we can see the gamma of 5/2. So this is for, so this problem is leaving to you, so you can solve it out. Okay, so next problem is, so gamma of minus half over gamma of half. So how it can be written? So if I write equals to, so if I write equals to, so minus half gamma of minus half, got it, again minus half. So this term, this in a denominator, we can write it as minus half. So I'm just doing the minus half, multiplying the minus half denominator as and numerator. So minus half of gamma half. Okay, now so this could be written as 1 by over, so this is minus half, so this is 1, okay, not 1, so this would be gamma of half, right? So you can check it out, and this is minus, sorry, so minus half times gamma of half, so 1 over minus half, so this could be 2. Okay, or there is another way we can do it. So or yeah, so the gamma of minus half over gamma of half, which is equals to gamma, again sorry, which is equals to gamma of minus half, right? And we can split these things, which is minus half times gamma of minus half, so which is nothing but 1 time over minus half. Great. And this is minus 2, sorry, this is minus 2. So the next problem is gamma of minus 3 by 2. So I can give you a hint, and next part is leaving. So the hint is, so you just so yeah, so the B part can be done. Okay, so gamma of minus 3 over 2, so if I just multiply minus 3 over 2 here and just balance this out, okay, so in such a format, so this is gamma of minus half. Okay, now so I'm just writing this to figure it out, what is the value of gamma of minus 3 over 2. So I'm writing this, okay, and so gamma of minus half can be written in this format, so you can check it out. So we need this value of this gamma 3 over 2 minus 3 over 2. So what we can do, so we can just gamma of minus 3 over 2. Okay, so this is minus 2/3 of gamma minus half. Okay, so so if you just do one more step, so we can minus 2/3 times minus 2, and this is minus half. Okay, and just gamma of minus half. So now your task is to figuring out the value of these things. So you can I hope you can do it yourself. So I am moving to next problem. So our next problem is, so here the finding value of this following integral. So we'll use gamma functions, and you will see that how I am implementing this gamma function over these integrals. So our first problem is integral 0 to infinity. Okay, so our function is the x cube times e to the power minus half of x square. Okay, so let us substitute. Okay, let us substitute. So t equals to, we are taking t equals to 4x. Okay, so this is for problem 1. So t equals to 4x, and so dt will be 4 dx, right? So dx is nothing but 1/4 of dt. Great. Now in our integral we'll do the substitution. So the limit will be 0 to infinity. Okay, so you just check it out from here. So you will find that the integral, the limit will be 0 to from infinity. And what we can do from this, so 1/4 of t, so this cube, and e to the power minus t, and dt by 4. So the constant, the 1/256 will be so 0 to up to infinity, and this is t cube e to the power minus t dt. Okay, so 1/256. So 1/256, the outer part, or we'll keep outside this constant term as we do in solving definite integral. So 0 to infinity, so t equals to 4 minus so e to the power minus t, and this is t to the power 4 minus 1 dt. So we can write 1/256. Okay, and this is gamma 4. So this is nothing but so this is 6/256. Okay, and this is which is nothing but 3/128. So this is the value of this integral. So we are done with this. Okay. Now the second one. So how we can do? So you just pause the video. You can pause the video and try it out yourself once. So let us do this. So say so we'll do this one. So this is, so we'll do the substitution again. So we'll substitute root over x. So this is t equals to root over x, and dx is, so dx is 2 times t dt. Okay, and if we do the substitution, the integral limit will be same, 0 to up to infinity, and this is t times e to the power minus t, and this is 2t dt. Okay, so as 2 is the constant, so we'll keep outside of this integral 2, so t square times e to the power minus t dt, so it will be nothing but 2 times integral 0 to up to infinity, and this is e to the power minus t and t to the power 3 minus 1 dt, and it could be written as 2 times gamma 3, which is nothing but 4. So this is how we deal with this sort of problems, and rest of 3 and 4 I am leaving up to you, so you can do it yourself and send it to me in my mail ID. Okay, so next problem. So it is asked that by using techniques involving the gamma function, find the value of the following integral. Okay, so so for the first one, we'll do the substitution like this way. Okay, so for the first one, so we'll do the substitution. So u equals to, so eu equals to natural log of x, and the du is dx by x. Okay, and so let us write that dx is nothing but x times du, and this x equals to e to the power u, right? And so as x equals to 1, then our limit u starting from 0 and x tends to 0, x equals to sorry, this is infinity, so our limit u equals to infinity. So that is, we can write and do the substitution like this way. So integral of 0 to up to infinity, right? And this is u cube over x square, and this is x times du. Great. Now, so how we can do this. So this is equals to 0 to up to infinity. So u cube over x du equals to 0 to infinity u cube. So this is nothing but e to the power u du, and now here, so this is u cube times e to the power minus u. So we can write this thing in this way. So e to the power minus u times u 4 minus 1 du, and that is nothing but gamma 4, right? And this is 3 factorial, and this is 6. So answer of this integral is 6. Okay. Now next we'll do this. Yeah. So you can pause the video once and you can try it out yourself with the help of this one. Okay. So here the substitution will do that. So let us do the substitution. So the substitution would be t equals to natural log of 1 over x. Great. And so it could be written in the form that t equals to minus natural log of x. So I'm just raising out these things. So this is quite easy. You can either you can use the formula of, or yeah. So this is so if I just cancel out this minus, this will be minus t equals to natural log of x. So we need the value in terms of x. So x equals to e to the power minus t, okay, and dx will be minus e to the power minus t dt, and the limits will be, so as x equals to 0, the t turning out to infinity, and as x equals to 1, t is 0, right? So we do the integral and change it. So we'll do 0 to up to, okay, so it will infinity to 0, t to the power a minus 1, and sorry again, so e to the power, so this is minus e to the power minus t dt, and we'll just change this. So we'll so this infinity will go to the top of this, so it will be turns into the upper limit, and this is the lower limit. So as we do that, so this sign will change. So this is a normal integral formula. So yeah, so this is infinity to 0 and t to the power a minus 1, and e to the power minus t dt. Okay, which is the exact definition of gamma A. So yeah, so which is the exact of gamma A, sorry, the gamma A. Okay, so this is how you can change, I mean you can follow up this integral. Alright, so we'll go to the next problem, that is 0 to up to 1 natural log of x to the power n. Here also we'll do the substitution of natural log of x, right? So you can pause the video and check it out. So let me do this favor. So u equals to natural log of x, right? And the du equals to dx over x. So as we want the dx here, as we are substituting, so you want this dx x times du, right? And the dx terms will turns around, dx could be written in this e to the power u du, right? So if I just write it in some sense, so and you see this minus t equals to u, and minus dt will be du, so minus infinity, so minus infinity turns into this infinity, and this 0 turns out to 0. Okay, and okay, and we do so. So this is how you can do it. So this is 0 to up to infinity, so minus t to the power n e to the minus t, and this is minus dt. So if I just do this integral 0 to infinity, and sorry again, so minus t, so minus t to the power n. Okay, so okay, so we are in right track. So dt, and this is minus 1 to the power n as 0 to infinity, and t to the power n. I hope you are getting this, and it is quite easy to handle. So this is dt, and this minus 1 to the power n, and it is gamma n plus 1. So you can write it in this format, minus 1 to the power n times n factorial. So your final answer is minus 1 to the power n in factorial. Great. So we are done. So next thing is it is asking that prove that this integral is equals to 3 times root pi over 8 times k to the power 5 over 2, where k is obviously not equal to 0. So we'll substitute this part. Okay, so we'll substitute this part so that we can write this in a quite e to the power minus x or something like that format, so that we'll implement the gamma functions here. Okay, so let this u equals to e to the power minus k k times okay, so this part. Okay, so k times sigma square. Okay, so we'll substitute this part, only this part. You can take this minus also, but we don't need that. So this is du of so rather making it bit of complicated, so let's write it sigma square k times u k over u. Okay, so this sigma will be root over k, and we can write this u, so root over k times u over minus half. So if I just derivative, so d sigma will be minus half of root of root over k time u to the power minus 3 over 2 du. So the limit will be changed into sigma equals to 0 and the u equals to infinity, and this if sigma equals to infinity and the u turns into 0. Great. So finally our substitution turns into 0 to infinity, and e over e to the power minus u over k cube times this u cube, right? And this d sigma part will write minus half of root over k u times u raised to the power minus 3 half of du. So if you just do a little bit adjustment, you will find out this is half of so this is half of k raised to the power 3 half, and it will 0 to infinity e to the power minus u and u to the power 3 half du. So half of k so k will be in denominator, so 3 half times, so this will be gamma of so it is 3 over 2. So if you just split it out, so you will find half of so 1 by 2k, 1 over 2k to the power 3 over 2 I mean, this is half of 2k, and this k raised to the power 3 half, and times 3 half of 1 half gamma of half, right? And you see this will be finally 38 times root over, so this is k to the power so it is 5 over 2. Okay, sorry, not 3 over 2. So yeah. So I have made a mistake, sorry. So this is 5 over 2. Yeah, this is 5 over 2. You can see. So this is 5 over 2, and this also be gamma of 5 over 2. Okay. So 2k 5 over 2, this is 5 over 2, and this is, so if you just split it out, you'll see, yeah, we are in the right direction. Yes. So this is, so 3 over 8, and in denominator k raised to the power 5 2, and this is nothing but root pi, so this is root pi. Okay, sorry, root over pi. So we are proved. So we have proved this, right? So in our next problem, it is asked that by using techniques of gamma functions, we have to prove this integral is written in this form, in such a fashion. Okay, so yeah, so we can do this. So let me change the color. So how the substitution will be done. So okay, so we'll substitute, so we'll substitute this k minus x. So let us, so k minus x, which is equals to u, and du is minus dx. Right? So as x equals to minus infinity, so the u will be u equals to positive infinity, and this x equals to k, and so this u turns into 0, and this x equals to k minus u, right? So we'll substitute and write this integral in this fashion, so minus infinity to 0, so e to the power a, this is k minus u, and this is u to the power n minus du, and this is easy, so this is infinity to 0, this minus terms will go cancel out, and will, so e to the power a times k, okay, so e to the power a times k will be outside of the integral, and u to the power minus u, okay, not u, this is, so this is u to the power minus n, okay, and this is e to the power minus a times u du. So so we can do another substitution here. So this so this t equals to au, right, and this dt equals to a times du. So limits, in this case the limits will be unchanged. So if we do so this is e to the power ak times integral 0 to infinity, so t over a raised to the power, this is minus 1 obviously, and e to the power minus t, and this is dt by a, right. So e to the power at 0 to infinity, okay. So okay, so e to the power ak times 1 over a raised to the power 1 minus u. I am doing this, okay, this is not u, I'm sorry. So this is n here, so it will be 1 over a to the power 1 minus n, so this is 0 to infinity, and t to the power minus n and e to the power minus t dt, which is equals to e to the power ak a to the power n minus 1, and this is gamma 1 minus n. So we have proved, okay. So one more important things I want to discuss, one more important problem. So before going to prove this, so before going to prove these problems, I am going to prove one more important part, which is 0 to infinity x to the power m raised to the power e to the power minus a x to the power n. So this is x to the power n, right, and this is dx. So it is written as gamma of m plus 1 over n, and this is n times a to the power m plus 1 times n. Okay, so this is quite a bit challenging in like to handle or tackling point of view, but it is not much more which you are so let's do the substitution here also. So we'll substitute we'll substitute the t equals to x to the power n, and you see this dx equals to n times not n times, so it will be dt over n times a x to the power n minus 1. Okay, and this x equals to, if I write x equals to 0, and it says that t equals to 0 and as x infinity, and this t turns into infinity. Okay, and if we write this, so 0 to infinity, so t to the power m over n and a to the power m over n, and this is multiplied with e to the power minus t, and we will write dt over n a times x to the power n minus 1. So if we write this 0 to infinity, 1 over a to the power m over n times n a, so t over m to the power n, so this will be x over 1 minus n e to the power minus t dt. Great. So 1 over n times a to the power m over 4. So let's write it more clear way. So 1 over n times a to the power m over 4 plus 1, right? And write this 0 to infinity. So I'll ask you to once cross check to doing this, because maybe I could be wrong. So 0 to up to infinity t to the power m over n, and we can write t over a to the power 1 over n, and this whole things will be 1 minus n and e to the power minus t dt. Great. And we can write it down again. So same thing again. So if we do so m, okay, sorry, why I have written m over 4? It's look like it is n, so it's look like 4. Sorry. So m over, sorry, my handwriting is too bad. So 1 over n times a to the power m over n plus 1. Great. And we can write it out 1 over n times a to the power m plus n over n, and this integral 0 to infinity t to the power m over n times t to the power, so this is 1 minus n over n, and this is again 1 minus n, so e to the power minus t dt. And if we do more steps here, you will see that okay, so this is 1 over n times a m, so m plus 1 over n, and okay, let me do, so this is m plus n over n times a to the power 1 minus n over n. Okay, so this is I'm adding this, so in a power, so this is in power these things, so it will be 0 to infinity. Okay, t over m, so t raised to the power m over n times t raised to the 1 minus n over n times e to the power minus t dt. Okay, and this is nothing but 1 over n times a, n plus 1 or n 0 to infinity. And yeah, this is quite boring, but and you need a bit patience to solve this out. M minus n plus 1 and this n and e to the power minus t dt. Oh, great. So in the next page, so we'll write, so this is 1 over n times e to the power m plus 1 over n. Okay, and this integral 0 to infinity, so t to the power m plus 1 over n minus 1, right? And this is e to the power minus t dt. And yeah, from this you can write this 1 over, so 1 over n times e to the power m plus 1 over n multiplied gamma of m plus 1 by n. So I guess this is what we want to prove. Yeah, we are done.